I don't know.
Maybe your students are just bad.
That's never the case. Students are just students. Here to learn. 11. You're supposed to use the concavity test. What is that? Second derivative. Let's decide where it's concave out of concave down. Tell me about the concavity of this part of this graph. 0. There's no concavity. It's a straight line. How about the concavity in this part of the graph?
2.
-2. Negative, right? So it means it's concave down. This part of the graph, no concavity. This part of the graph, concave down. Okay. So if we graph this thing, just thinking about it. We graph it, it switches from one function to the other. X equals 1. For less than 1, it's this line y equals 2x, so slope of 2, so kind of like that. And then to the right, it's 2 minus x squared, like 2 minus x squared, so it's this function. So this is an open circle, right? This is a closed circle. So that function. That's got to make sense to you. So we already know the answer before we start the problem. Here's the concavity test. So y prime is 2, negative 2x, x less than 1, x greater than or equal to 1. Y double prime, that's not very good, is 0 and negative 2. Oops. I guess if we using the concavity test, we should use it. Second derivative is probably undefined. It's where it switches. It's not even continuous here, right? So 0 and negative. That means it's concave down. And then to answer the question, A never, B x greater than 1. Yes.
So I did a problem a little different next one, if you would like as well. What I did was to find the derivative, I added 2x with 2 minus x squared. Like I set them equal to each other.
Now these are two completely separate parts of this graph. There's not one point where they're related. It switches from this graph to that graph at 1. Not continuous at 1. Any questions?
Can we do one more of those?
Yeah, you want to see one at like 7?
Yeah. Or 12, or both.
Well, this function from 0 to 2 pi, weird.
Did we already do that? We actually might have already done that one.
E to the x is always concave because it's an exponential function. It's always increasing. It's never negative. It's never 0. Any positive number to any power is always positive. That one's got some interesting things to it. So y prime not nice. But we're not trying to figure out where it's increasing or decreasing. Now on the test, it'll be a function that factors after the first derivative and also factors after the second derivative. Those are hard to find. There's probably only 3 or 4 out there. Okay? Now we don't have to do the second derivative test, or first derivative test, obviously, we'll do the second derivative test. What is this? 32. It's 221s. 6 times 7. 6 comes out. So what's the sign in the second derivative to the left of -7 fourths? Or -500. Sign in the second derivative. So this is labeled as negative. That means the function's conjugate down there. How about the sign, second derivative for any number to the right of -7 fourths, like 0. Positive. That means functions concave up. So for A, we're missing where it's concave up. That's, we're not in algebra 1. -7 plus 2. And B, where it's concave down, negative infinity to -7 fourths. Okay? Any questions? Okay. 15. Find all points of inflection. Y prime. Do you guys know what inverse tangent looks like when you graph it?
Oh, no, that one you graph it, but that's what's
Well, tangent is always increasing when tangent's 0. Tangent is 0 when x is 0, when theta is 0. Right? It's always increasing. Inverse tangent is always increasing. You look at tangent in between pi/2 and -pi/2 and pi/2. So the inverse goes from -pi/2 to pi/2. Tangent's always increasing, inverse tangent's always increasing. Just like this. I'm supposed to do that. Okay, that's what inverse tangent looks like. So where's the inflection point? At 0, right? When x is 0, there's the inflection point. It changes from concave up to concave down. Okay, so there's the answer. So let's see if we do the work and get that answer. First derivative is 1 over 1 plus x squared, which is 1 plus x squared is negative 1, 1 plus x squared, negative 2 times 2x. And that is 2 negative 2x over 1 plus x squared squared. We're looking for where this is 0 or undefined. Is it ever undefined?
No.
Why?
Because it's always
X squared plus
Mostly true, right? X squared, the smallest it can be is 0, right? 0 plus 1 is, smallest that can be is 1. 1 squared is always going to be positive. So this is never undefined. There's a value of x that makes it 0. So we'll set this equal to 0. Actually, doesn't matter. So, let's label y double prime. We can check the sign of the second derivative for numbers to the left of 0. Like negative 1,
It's positive.
positive. And to the right of 0, like 1, negative. That means the function is concave up and then concave down, which we already knew, right? And do we just have to say that? So concave up. Bless you. And concave down. What's that? Inflection point?
Zero.
That's an equal sign. Okay? That's everything. Any questions? 24. So this is the graph of f prime. So if we do an f prime test, we have to look at the graph of f prime and see where the graph of f prime is 0. What values of x approximately are f prime 0? This is the graph of f prime. When is the graph of f prime? When is f prime 0? It's 0 for sure. What else is at 0?
1.5.
1.25.
It's just like a little bit.
No. F prime is not 0 here. F prime is 1, 2, 3. F prime is 4 there. Where's f prime 0?
Oh, 2 and negative 2.
Can we get that? This is the graph of f prime. We're looking at f prime. When is this 0? 0 here, here, and here. What is the sign of f prime to the left of negative 2? To the left of negative 2. It is negative because it's below the x-axis.
Oh, yeah.
What's the sign of f prime in between negative 2 and 0?
Positive.
Positive. It's above the x-axis. What's the sign of f prime between 0 and 2?
Positive.
Positive. And after 2? That means f, which we don't know what it looks like. We do know that it goes down and then up and then up and then down. That's what we know about f prime. That's what we know about f. Okay. Now let's do an f double prime test. Good. Wait. Not in green. Okay. F double prime. So F double prime is the slope of F prime, is the derivative of F prime. And we're looking at F prime. So where's the slope of what we're looking at? 0.
1
1.
minus 1.
Let's call it 1, 0, and negative 1. Okay? Good. What's the sign of F double prime less than negative 1? Because the slope of the tangent line of F prime, the derivative of F prime, the slope of this curve is positive. What about in between negative 1 and 0? So it's decreasing there. The slope of F prime is negative, and then from 0 to 1. Positive because it increases, and then 1 to infinity.
Right.
That means F is concave up, then concave down, then concave up, then concave down. So we know everything we need to know. Did we not? We didn't have to do. Doesn't matter. It's good. It's good. So, increasing. Increasing max min concave up, concave down, inflection points. Sure, that. How do I answer those?
Increasing from
Increasing from -2 to 2,
What's your answer?
and then decreasing.
negative infinity to negative 2.
Yeah.
I would probably do this.
You got 0.
But on the AP exam, answers, do what you do. Negative 2 to 2. Because that point where it has a vertical. No. Where it has a horizontal tangent line, it increases and then increases some more. That point is a little bit higher than the one to the left and a little bit lower than the one to the right. So it's probably included in the points as a point where it's increasing. So your answer's probably better than mine, but I've always separated those two. I would not lose a point on the AP exam, but that's what I always do. When is it decreasing?
Negative infinity to negative 2. Until 2 to the positive infinity.
Good.
And
Yes?
your answer will be wrong in the exam?
No, it would not be wrong.
Okay. So both are acceptable.
Yeah. But Carlos is probably better. I just haven't changed the way I think about it.
I mean, they still pitch it your way.
They would not take off. Yes.
Are they parentheses because they're not included? Or is it just not the filings?
They're parentheses because they're not included. I don't include them. That's, I do. That is the same as this, and they're both right. So we could have square brackets there. I would not include -2 and 2. Every time that I've taken those classes, they've always said that they won't take off if you have square brackets. They say doesn't matter if they're curved or square brackets. That's what they tell me. Maximums.
1 and
1 and
Negative
4.
one.
Oh, maximum is at
negative 4, pal.
1 and negative.
I still haven't heard one correct answer.
a maximum.
Where?
-2, 0, and 2. So
Still no correct answer.
Let's
One
keep trying.
third of a correct answer at this point.
0, 2.
So this is the maximum because there's no sign change in the first derivative.
4.
This is
1,
not maximum.
-1 and 4 and 1.
This is not a maximum.
Negative 1, 4.
It's a minimum
Wouldn't it just be
because it goes down and then up. This is a maximum.
0, 2.
So
X
it's
equals 2.
1 and 4. Or x equals 2.
Add. Why? I don't know why you guys aren't giving me the way I like this. X equals 2. F of 2 is, oh, we don't know what it is. Because we don't know what the function is. So that. How about the minimums?
At x equals
And -2.
That's
X
the
equals
only one.
-2.
At x equals -2. Concave up.
negative 3, negative 1.
-2.
Again.
Concave up from -2 to 2.
One to two.
Zero.
Zero to one.
From 0 to 1.
Okay. Concave down.
-1 is 0 and 1 to
Inflection point.
-2 and 2. Oh, no, no, no.
Negative
-1, 0, and 1.
Okay? There has to be a sign change in the first derivative for there to be a maximum or a minimum. There has to be a sign change in the second derivative in order for there to be an inflection point. Any questions? Those are awesome questions, you guys.
40. Mr. Bush, 48 second, kind of like a drawing a graph one.
48.
Could we go over that?
Oh. Oh, yeah.
Because we've done the inverse where it's like,
This is so. AP exam question. Sure. Two. All we have to do is graph it. And 2 is a horizontal stream. Up to 2 is falling in concave up. I really don't need calibration to be off right now. Falling in concave up. And 2 horizontal. 2 to 4, rising in concave up. Four inflection point, 4 to 6 rising and concave down. 6 horizontal tangents falling in concave ground. There we go. Yes.
Don't you have to have points at 2, 1, 4, 4, and 6, 7?
Oh, I didn't see that they gave us points. Oh, that's kind of fun. 2, 1. 4, 4, 6, 7. Beautiful. Thank you. That's important. I just skipped over those. I don't even know why.
50.
Any questions? Let's go.
3, 4.
I don't know what I'm doing today.
It's just more
There you
fun.
go.
Yeah.
More 5, 3.
More it's-
I should probably check and make sure we got through those notes. It's all written 5 times. Three, 4 minutes, so no problem. You might
Give me too much time.
If, okay.
Are we here?
Yeah, we haven't done that yet.
So we're trying to find the velocity and acceleration, find the velocity and acceleration discrepancy. So, take derivative twice. Why is this coming out?
60 squared minus
28.
24.
Minus 28.
28 T, my bad.
T plus 22.
And acceleration.
Acceleration is
Gonna be
12 T
12 T
minus 28.
Probably moves back and forth. Velocity is sometimes positive and negative. Can we graph this thing? Can we factor this in?
First one.
What a
3T is
2T squared minus 20 minus 14 plus 11.
It factors.
It does?
wow.
Right? It's nice. I like it too. That's correct. Okay. N equals 0. T is 11 thirds. T equals 1. Right? So we know that it increases to 1, decreases to 11 thirds, increases at compromise. Should n equal to 0.